In this lesson, we are going to discuss law of conservation of momentum. At the end of this video lesson, you should be able to describe the interaction between two objects in terms of the change in momentum of each object. Suppose there are two bowling balls. Bowling ball number 2 hit bowling ball number 1, which made them move separately after the collision. Before collision, the momentum of the two balls is 0 since they are at rest. But during collision, the mass of the second ball, which we denote as m sub 2, exerted the force f sub 2 going to the left to hit the first ball. In return, the first ball with mass m sub 1 exerted the same amount of force to the second bowling ball but in opposite direction. The forces exerted by the balls onto each other allowed them to move in a certain final velocity of v sub 1 and v sub 2 respectively. We now know from our previous discussion that the product of an object's mass and velocity is its momentum. This gave the two balls a final momentum of p sub 1f and p sub 2f respectively. To investigate the three events of the collision, we have these figures. Before collision, the balls approach each other. During collision, the balls exert force onto each other. And after collision, the two balls move away from each other. The momentum of the two balls before collision describe their motion as they approach each other. We denote the momentum and velocity as before collision. On the other hand, the momentum of the two balls after collision describe their motion as they separate from each other. We denote the momentum and velocity as after collision. Now, using the impulse-momentum relationship, we can describe how the forces exerted by the two balls onto each other affect their momentum. First, let us look at the force exerted by the first ball onto the second ball. It is given by the impulse of ball 1 on ball 2 is equal to the momentum of ball 1 after the collision minus the momentum of ball 1 before the collision. And second, the impulse of ball 2 on ball 1 is equal to the momentum of ball 2 after the collision minus the momentum before the collision. During collision, the two balls became a system and have one momentum. It is given by the sum of the impulses of the two balls is equal to the sum of their individual momentum. To isolate force, we can factor out the change in time from the sum of the impulse equation. Since the forces exerted by the two balls onto each other are equal but in opposite direction, the sum of their forces is 0. Thus, we can equate the change in momentum to 0. With this, we can now see that the momentum before collision is equal to the momentum after collision. It can be simply written as m sub 1 times v sub 1 plus m sub 2 times v sub 2 is equal to m sub 1 times v sub 1 prime plus m sub 2 times v sub 2 prime. The apostrophe or prime symbol denotes the quantities after collision. It is only applicable to the velocity for this type of collision since the masses of the two objects did not change after the collision. This equation, which tells us the momentum before and after collision is conserved, is what we call the law of conservation of momentum. Take note that the momentum is only conserved if no external forces are acting on the system. Let us look at a different example for the law of conservation of momentum. A 0.04 kg marble moving with a speed of 2.0 meters per second strikes a 0.04 kg marble initially at rest. As a result of the collision, the first marble comes to rest and the second one moves in the opposite direction. What is the velocity of the second marble? Let us identify the given quantities in this problem. The mass of the first ball is 0.04 kilograms. It is initially moving at 2 meters per second. Thus, we have v sub 1 before collision. The mass of the second marble is also 0.04 kilograms. Since it is initially at rest, its velocity is 0. The second marble went to a stop after collision, which gives it a velocity of 0. Now, we are going to solve for the velocity of the second marble after collision. For the solution, we are going to use the equation for the law of momentum, which states that the total momentum of the system before collision is equal to the momentum of the system after the collision. Writing the complete expanded formula, we have this. Since we need to isolate v sub 2 prime, we need to subtract m sub 1 times v sub 1 prime on both sides of the equation. We then divide both sides of the equation by m sub 2. Thus, we have this working formula. Plugging in the values, we have v sub 2 is equal to the product of 0.04 kilograms and 2 meters per second, plus the product of 0.04 kilograms times 0 minus the product of 0.04 kilograms times 0 all over 0.04 kilograms. We can cancel the two products above, which would result to 0. And we can also cancel 0.04 kilograms from the numerator and the denominator. Thus, the velocity of the second marble after collision is 2 meters per second. To check if the momentum is conserved, we can use the expanded version of the conservation of momentum formula. Plugging in the values, we would have 0.08 kilogram meters per second as the momentum of the system before and after the collision. To wrap it up, let us review the following key points. Objects in collision will exert forces of the same amount but in opposite directions with each other. And the total momentum of a system does not change if there are no external forces acting onto it. And that ends our discussion on law of conservation of momentum.